So today Eugenio is presenting. He's a postdoc at the Imitating in Brest, and he's visiting the group of Ananda Pasquale. And today he will talk about artificial intelligence. As they say, the floor is yours.
Okay, thank you, Sophia. She said I'm doing a postdoc mostly in AI-related team with the ocean in the Atlantic, but today I'm not going to talk too much about my research. We thought that maybe it could be of interest for the general public of Imitating, having some hints on what's going on in the artificial intelligence, especially toward the artificial general intelligence. So there will be a lot of information about hints about what is going on and how, in general, AI it's inspired by nature. The development of new algorithms and techniques is driven by what nature is doing. So there is two ways, no? For a side, we learn from nature, and of course we can use these tools to learn more about nature. So since I think it's the most common AI that everyone is using daily or weekly, ChatGPT. Let's see here a graph of how many users start using ChatGPT after the release, and I suspect that many of you it's using every day. I will try to explain you a bit how this is working and how this can be extended towards our research in more broad sense. Okay, so first of all, let me introduce a key concept that is the basic of science, but it's going to be useful along this talk, is the fact that if we want to improve something, and in this sense, we want to improve AI, we need a way to measure how this is going for our objective, let's say for language. So in order to understand how ChatGPT is working, let's try to make an example. If you have this phrase here in Spanish, luego tomamos, I suspect that most of you have something in their mind, knows how to continue that phrase. And since I've been many here in Spain, here on the left you have my educated guess. Let's say that many of you will say maybe a caña, someone of you is going to make a coffee, ask for a coffee or a coca or something else. But instead, someone, let's imagine that someone just arrived in the island, don't really know the habits here, and so maybe don't know even the language. And so the guess, it's less precise. The concept that I want to introduce here is the concept of entropy in the information theory. And the idea is that if you are pretty sure about your guess, okay, there is a distribution that you have of your possible outcomes. It's pretty low entropy. Okay, so you have high confidence in a particular choice. And instead, someone else that do not really know what's happening, it's going to have a more flat distribution. This is the case of high entropy, low confidence. And why this is important? But because we want to measure how these two distribution differs. And this is, for example, the case if you go with the Spanish that you learn in Spain and you go to Latin America and you want to use this phrase, you're going to discover that the distribution is totally different because they use luego tomamos el bus, no? You're going to take the bus. You're going to use different way the language. And the fact that the two distributions do not overlap means that you are going to be surprised or perplexed somehow. And this is actually why we are interested in perplexity or surprise, because from our neuroscience studies, we know that the brain is actually pursuing all the time to minimize the surprise, to make a model of the world that is going to be, is going to know what is going to happen next. Okay, for example, studying a lot our eyes, you may suspect that our eyes is communicating all the time with the brain through nerves. Instead, it's more the reverse process, because it's the brain that is telling to the eye all the time, you're going to see this now, you're going to see this. And when there is a difference in that, okay, the eye tells the brain, okay, no, this is different. Okay, so the brain has a model of the world, and when it's surprised by the eye, it changes the model, update the models. Okay, this is more or less how the brain works. And with artificial intelligence, what we want is to copy, to imitate this cognitive function in general. So this is a big box of artificial intelligence. Inside we have the terms of machine learning, the ability to perform tasks without supervision, without explicit instructions by machine. And then there is the modern term of deep learning, that it's regarding artificial neural networks that are based on, the artificial intelligence that are based on neural networks. I know there are too many terms. And then not to want to stress you too much, but what is a neural network? Well, it's not something really complex a lot. It's just that if you have an image, if you have a text, an audio, any kind of data, of course, you have to convert that in numbers. And then these numbers are going to be just with easy operation, multiply, add. So really easy operation. So let's say that you have a photo, you convert that to numbers, and it enters in the neural network in the green area, in the green neurons, and then goes through a process of multiplication, addition, or whatever, easy mathematical operation until it reaches the output. And the output, if you train well your network, later we're going to discuss about that, is going to tell you with numbers, of course. Maybe if you want to choose, if you want to decide if this photo is of a cat, of a dog, of a bird. Once again, here there is the concept of entropy, like what to choose, what is your guess? First we talk about luego tomamos, and we have to decide the word. Here we have to choose what is the right category. And the key concept here is that neural networks really works with easy operation, but many of them in many deep neural networks, because there are many layers within that. Okay, and this is also the reason why we need GPU. You maybe heard about the phrase an infinite number of monkeys. If you let them typing on a computer, in a certain amount of time, they can write the same stuff as Shakespeare. Okay. Well, the idea is that CPU, the common computers, are optimized to sequential processing with high precision. Instead, with neural networks, we don't need that. We need really fast operation that are not pretty precise, but they are really parallel. Okay, so this is why we need that. They were developed for video games, but this is were really useful for training neural networks. So really a lot of operation, really fast. And some remarks still with how the LLM, large language model, works, so ChatGPT. The idea is that if you want to work with language, what is the input and what is the output? Well, the input, of course, it could be your question or a part starting of the phrase, like in our example in the beginning. And then what the network is doing is the retro, it's kind of a loop. Okay, like it's autoregressive. Autoregressive means that you put a part of the phrase as the input, then you obtain an output that is a word, and then you take this word and you re-enter into the network. Okay, this is why it's autoregressive. So it's like a loop, like this famous illustration of Esker. It's retroalimentated until the end of the phrase. But okay, so this is how the natural language processing was working more or less 10 years ago, and it was working, well, more or less good, not particularly good. And the real breakthrough, really break-even, was this paper mostly from Google people that is called "Attention is All You Need." And what they say in this paper, that maybe if you want to process language, you don't have to go word by word, how we saw in the slide before, but instead you have to try to correlate each word with all the rest of the words of the phrase. Okay. And this of course was developed for translation, because, for example, in German language, the verb, it's in the end of the phrase, so it's kind of hard to understand the meaning of a phrase if you proceed word by word, because maybe the verb is just in the end and you cannot really understand until you reach the end. So in this way, each word is correlated, and then you discover how much each word is important for some other words. Okay, so the verb is going to be more important for the subject, and so on. You can see a scheme here. For example, in our phrase, the fact that the right answer could be a caña. Okay, a lot of weight, it's on the temporal side. The fact that the verb, it's related to drink. Okay, and maybe also about the subject, but just to give you some hints on how this is working and how this was revolutionary. Of course, until now we are talking about words, but the same technique could be used for images. We are usually talking about token. It's a way to transform word into numbers, but we can do exactly the same for images. And we can also split an images into small patch, and this small patch enters into the transformer. Sorry, I didn't mention, but this paper is presenting the transformer algorithm, transformer layer, and it's the T in GPT, it's transformer. So this is generative pre-trained transformers. And this can be used also for images in the recent transformer, as I was saying. And we can split an image into patches and then process with the same way, with the attention part. This is the most important thing. The fact that each part of the images is related to something else. Okay? And why this architecture, the transformer architecture, is so famous and it's so common? Well, of course, it works good, but another good point of this technique is that provides you a way to understand what the neural network is doing. You know, one of the common critics is that it's a black box. Once you put something in a neural network, you don't know what it's doing. Well, at least with the transformer, you have an idea of what it's doing because you have the so-called attention map that gives you an idea of where the network is looking to take some decision or another. Okay, so for example, if you want to analyze radiography and decide if it's COVID or not, you have the points in which the network is watching to decide, okay, this is a patient that have this kind of pathology. And the same if you want to categorize satellite images or time series, exactly the same. And of course, even language. And okay, until now we see what we can do with neural networks, but we didn't talk about the really important part, that how we train this network. And let me just recall this concept from Maria Montessori, that it's a famous Italian pediatrician, or I thought it was saying pedagogist, but yeah, she studied a lot the best way for kids, for children to learn. And one of the key ideas of her method that probably also inspired most of the Silicon Valley people, that most of the famous one studied in the Montessori school, that the fact that the best way that you can teach to kids is that they learn themselves without supervision. And this is actually what we want to do also with neural network, with transformers and so on, because the old way, the canonical way that you maybe have heard about is the supervised way, in which, for example, if you want to categorize photo of birds, of cats or dogs, animal, you need to provide a lot of example. And this is kind of slow. And one example to understand why this process is slow, let's say that you are staying in the Puigmayor, the biggest mountain here in Mallorca, and you want to reach Palma or Inca, and you don't have a map of the island, but you just have a photo of where you should arrive. And so you just go more or less randomly. Of course, you can go, since you know that Palma is down, you go where it's steepest, but then it's really easy that you can get lost. For example, you can reach Kuber, and you know, this is, okay, I'm right, there is no more to go down. But instead, you have to reach a really far place, and you can get stuck really easy, and this is a slow process. So nowadays, there are techniques inspired to the idea of unsupervised learning or self-supervised learning, where the neural networks learns on their own. And one of the way that I'm also personally using is generative adversarial network. It means, and also this is inspired by nature, that a way in which the neural network can understand the work and generate, for example, this is used a lot for generating images, it's through competition. Okay, so you have two neural networks. One could be the generator, the painter, and one it could be the discriminator, or let's call it the detective, that aims so the generator is trained all the time to produce something cool that the detective then has to decide if it's good enough or not compared to real data. So in this way, you are not saying, okay, this is what I like and this is what I don't like. You just provide examples of real data. Okay, so this is a continuous training in which they learn how to fight each other and to improve themselves all the time. And I personally have been using this kind of technique for satellite images. You know that Ananda's group is working with this satellite altimeter, SWAT. And the problem of this satellite that is, since it's a new instrument, there is a lot of noise in the measurements. And so a way in which I found a way to remove this noise and try to make an analysis of the ocean state is through this kind of technique. Okay, so the generator takes the input and then generate a possible ocean field, and you can actually generate an ensemble, like how the same way in which, for example, you can generate thousands of fake cats or images with AI. And okay, just to mention the idea of the attention map, I'm using that to understand what's the physics behind the process in the ocean. The attention map that I showed in the beginning, just to show a particular application. But a further way, now we are seeing, just to give you an idea, just trying to show you all the possible techniques in which the neural networks learns on their own without too much supervision. So another one that I think someone of you knows, because it is behind a pretty famous algorithm, which is called grounding Dino. It's okay, of course, it's called Dino, and the idea is distillation with no labels. In this case, there is no competition, but there is a cooperative behavior, always from two neural networks. One is the student and one is the teacher. And what's the idea here? That you have an image or a kind of data, and you alter this data, you add some noise, you cut a bit of part of the images, and you provide this different version of the same data. This is also cool because you don't need too many data for training data. So you modify a bit of this data, and you provide to do two different neural networks. One is the student and one is the teacher. And the two, they are equal, they're exactly the same architecture usually. But the cool thing is that the teacher is going to learn in a slow way, let's say. It's going to be more conservative, while the student is going to always look for something different. Okay, this is cool. I want to learn this and that. And in a way, during the training, they have to agree on what is within these images. So, for example, is that a code? Yes, a code. Okay, so this is a way in which cooperatively they can achieve a common understanding of what is in an image, a time series, or so on. And actually, this is what we use with Marco Signoroli in the PEP group. And maybe also a lot of you is using grounding Dino for segmentation. And this is a work that is still in progress, but we use that to measure the size of the fish. And then with another neural network, we try to identify the species, always on the way. And another application of Dino and also transformers, so the one that you saw in the beginning with ChatGPT and so on, is to analyze time series of trajectories. They have these super cool experiments in the Palmas Bay, in the marine reserve, and they track with acoustic tracker many fishes. And so they collect a big amount of trajectories that now, in a work that is also in preparation, we are analyzing with transformers, also with Dino learning, to understand what are the common behaviors, what are the on range. We understand that with neural network, we can have a skill score to compare different behavior, different way in which the fish moves. And the next, also next development, it will be to be able to simulate animal trajectories in a way that we can understand how animal behaves according to predator or some change in the environmental condition. And then finally, really quickly, another way to learn without supervision is just recalling how the kids learn when they are destroying things. You give them whatever, and then they destroy it, but in this way, they also understand how it's made. And the classical example could be a sandcastle, that it's somehow a complex data distribution, how the shape of the castle is made. But let's imagine that you destroy it really with slow movements, and you remember what you did when you destroy the castle. In this way, if you remember exactly what you did, you can then reverse the process, and then from noise, from the box of sand, you can get back to the castle. And actually, I'm starting to use that. This is still a work in progress for the so-called ocean digital twin, in which you can take measurements of the ocean, spars from satellites and from in-situ observation. And then once you learn the complex data distribution, you can generate an ensemble simulation of what's going on in the ocean. Okay, then beyond that, there's this big question of is this real intelligence, real artificial intelligence? And of course, there are many debates, mostly philosophical, about what it means to be intelligent or not. And so we can just take this phrase from Einstein, for example, the fact that intelligence is the ability to change. And with GPT until some months ago, the idea, as I said, T is for transformer, but the P is for pre-trained. It means that this model is not learning on the fly. You train with a lot of computers, a lot of times, these neural networks, and then you cannot change while it's working with you. While you chat with ChatGPT, you cannot change the way in which GPT looks at the world. And there was a way, as I said in the beginning, it's important to have a way to quantify how this neural network were able or not to understand something new. And so there was, I think, no, there is not a year, but 1 or 2 years ago, they developed this test that it's kind of, it's made up by puzzle, easy puzzle, that any human can solve pretty quickly. Okay, so for example, you have the box here, that there is this part, and you know that you have to remove the part of the square. No, there are many of these puzzle that you can learn on the way. What are the rules? You have an example of what is the right answer, and then you have to guess the following question. Pretty easy. But AI were not able to, GPT model in particular, were not able to deal with this kind of problem. Okay, so they said, okay, cool, now we have a way to measure how AI is not able to mimic the human intelligence, the human common sense, let's say. Well, this was true until some months ago, until December or October, when the OpenAI released ChatGPT 03, that suddenly shows to the world, and this was a kind of scary moment, let's say, that this benchmark, the ArcGI test, that were kind of hard to guess, the score were pretty low, suddenly, boom, they blow up. So they were able to understand a problem, a new problem, and learn it on the way. And another benchmark that I think it's relevant in this context is the fact that this same model was the first one that the 01 series, 01 and 03, were the first model to overcome a human PhD in its field using Google about some topics. This is another benchmark, GPT-2EA, which you have to answer to really difficult questions on chemistry, physics, biology. And they show that this model that it's able to rely on a huge amount of knowledge and on reasoning was able to outperform a human PhD. And how this is working, this is just to be aware of that. And a metaphor, last one, promise, to understand how this model were able to reason. It could be, I don't know if you ever played the game in which you have a character in your head and you have to guess what character it is based on your binary questions. Well, if you played a lot with this game, you can feel that the players in these games, in the beginning, they are pretty dispersed. They, just make a random question, silly questions. But then, as soon as they play, they develop a strategy. They make really specific questions because they know where to look for their characters. And this is called Monte Carlo research. So opening a tree of possible questions and then follow the branch of this tree. And of course, you can give a reward to a neural network, exploring different way to reason on a topic once you reach a good achievement. And so this was done mostly with mathematical problems. So you give mathematical problems to an AI and then say to AI, okay, try on many different ways with Monte Carlo research. And then I'm gonna give you a reward just if you, in the end, you got the right solution, okay? So it's easy to check if you have the right solution. But then these strategies that you can use for mathematical problem, they discover that this is useful in general. So in this way is how they teach to an AI to reason. And furthermore, this was an also pretty commented moment in the media. It's from a Chinese company, it's called DeepSeek. And in the community, it's known how the, okay, how to say that, aha moment. Because in the good things of this startup that release all the code and a really useful paper about how they train the reasoning LLM, reasoning model, and they were able to follow the reasoning of the LLM and understand that while the model was trying to solve a mathematical problem, it says, okay, wait, maybe I'm wrong, I have to get back, you know? Okay, so it's not like the first version of GPT that just vomited you the first things that was in their mind, in their training, but instead this model was able to understand that maybe different paths should be taken. And okay, there is a lot of comments about the fact that this startup was collecting people data and so on. Again, maybe this could be true, but something that it's a bit scaring is that, I mean, for the good or for the bad, that this is an open source model. It means that if you have an enough powerful computer, I'm talking about an expensive one, you can run a model, and you can have more or less in 100 gigabyte the knowledge of the world in many sense, and you are not controlled by governments. You know, you can actually, if you play with this model, you have access to how to make weapons, how to make biological weapons, how to make terrorist attacks. So my personal view is that people are not concerned about the fact that the Chinese are collecting the data of the people, but the fact that Chinese are releasing that as open source. You know, so usually we heard that open source is something good, but now we are in the moment that we don't know what to say. Okay, it's kind of a debate. And then on the last step, this is the bit related of what is my curiosity, what is the next step toward developing something really similar to our mind. Is the concern, it's the question about the fact that our brain, it's using more or less 20 watts. So the energy that it's using is not a lot, the power that it's using is not a lot. And instead, an artificial neural network is using much more energy, and of course, is still more stupid than us. Well, one of the reasons of why this is happening, it can be detected more or less by the structural seeders. You see, you know, this is the graph of the artificial neural network, for example, and this is our brain instead. And one of the problem here is that it's also related with the fact of being slow, that to train a neural network, you have to process the information along all these neurons, and then once they reach the output layers, you tell to them, okay, this is not good enough. So you have to talk to all the neurons in the behind you in the cascade to improve their concept, their weights, their operation, the mathematical operation that they are doing. So this is a kind of global training, you know, like long process up and down from the beginning of the network to the end, and this is really slow and energy consuming. Instead, our brain works with local training. It's called, and in this way, the brain is able to, the neurons are just trained on a resonance, topological resonance called within their neighborhood. And this is a much more efficient way to train and to learn something. And actually, this is also what was discovered by a Nobel Prize in Physics in Taiwan about how the birds moves. This was a kind of curious because they just put a lot of camera up in their Rome train station, because there were many birds, and then they study their movements, and then they discover how birds synchronize in a really topological way, in a really unsupervised way also, but just looking at their neighborhoods, they were able to coordinate themselves. So this is what we actually would like to achieve also in artificial neural networks. And there are many contributions coming in the even month by month. One recent one from a PhD student in Granada was related about the fact that if we were able to structure the topology, the architecture of the network in a way that some resonance, some frequency of synchronization could appear, then it would be much easier to train, to understand the network and how the signal propagates into the network. And this is also related to something that I heard many times here in Imitating, that in biology, I think it's pretty statement that structure determines function. So little by little with AI, we're trying to understand this. And then on some final remarks, of course, you can imagine I like a lot these topics, but at the same time, I'm not sleeping too good because it's many different people now. I just put 2 here, but there are many people commenting on that. And beginning from Alan Turing, that is considered one of the informatics godfather. There are many concerns about what's going on when the AI are going to be smarter than humans as a species in general. And another comment, just to have a kind of continuity, this is a Nobel Prize in physics, but actually it's the reason for the Nobel Prize was the development of the neural networks. It's also kind of scared about where we are going. And many people say, take care because this is, and I agree, this is kind of like nuclear, when the nuclear energy was developed, all the community and not just scientists were talking about that. And I think this is the moment for doing the same with AI. Some people were proposing also to build something like the CERN, the CERN for high energy physics, make the same for AI, so we can study as a community, as a global community, what's going on with AI. Instead, what is going on nowadays, each private company is developing its own AI, and there is no control on that, and it's kind of scary if the profit is the only aim, of course. And so my personal outcomes in the end of this talk, of course, it's ChatGPT, it's really common, and other AI are really useful. Maybe my suggestion would be to use it not to write more, because of course we have to publish, write papers. But I think that the real power of this technology is that you can read a lot and discover many new concepts and understand more, study more. In the end, it's like having a teacher on your side 24 hours a day. So it's really useful to, at least to my side, to understand more what's going on in the world, even in different fields, in fields that you maybe don't know directly. And then there is this fact, there are many people saying, okay, maybe 2 years, maybe 5 years, maybe 10, but the idea of an AI that it's able to overcome human, to outperform human in all the economical tasks, especially, is going to happen relatively soon. So we have to deal with that fact. And of course, if you want to take care about your jobs, well, one suggestion could be to enhance your soft skills, something that maybe makes us human, like how we deal with each other, how we deal with communication problem, and so on. And of course, since it seems like the world is going to change, it's going to change really fast in the following years. Of course, there is always the idea of having a caña, having a beer, and enjoy life. And just as a final remark, there's also the hope by some other people that see that with AI, maybe we can achieve what Elinor Ostrom was telling from many years, that what we lack as a species is a way to coordinate ourselves and have some kind of collective action that is not just one against the other. And maybe AI will provide the technology to do that. And this is, thank you. Questions or no?
I really like the talk. I am personally very scared about this. But apart from this, you have shown that there are different ways of improving, for example, the recognition of images and everything.
Yes.
And which one would you recommend? Because you have shown different ones,
yeah.
But which one is best, or how can
well,
we know this? Or
There is not an universal answer because it depends a lot on the data that you have. If you, for example, with Marco, we are working at this problem of classifying fish, which we don't have many images on about each species. And so in this case, there are different approach called few shot learning. So if you have just few example of the images, there are libraries specialized on that. And so Dino is one of the library, and then there is another one that is called JEPA, or with Ota, with J, that it's also based on not having too many data, but mask a bit of the data and try to understand what it's in this mask that you put. And this is working also quite good in a way that you achieve a numbers, or let's say or in the beginning a distribution that it's unique. So if you give one kind of images, you have one kind of representation numbers. So I can give you the link, but Dino and Jeb are one of the best for few shot learning, let's say, if it's the case, but depends a lot also in
How many are your, how many?
like 10 photo for each class, let's say.
Oh, 10?
Yes.
Oh, that's not much.
Yeah.
Okay, I thought it was, I don't know, 1,000.
Yeah, this was in like, because even time, in this kind of studies, it's kind of delayed. Like 2 years ago or maybe 5 years ago, this was the way to do, like having 1,000 and 2,000, 10,000 images and train with that. But now there are ways which you could deal with data lacking, with the fact that you don't have so many data.
Oh, that's very few.
I'm not saying this is gonna work yes or yes, depends also on the quality of the images and so on.
Okay, so what you do is to try different kind of Dino and then the other. and
Yes,
check
yes.
what is best?
Yes, exactly. Usually there are, actually with Marco, we are doing some benchmark. It's not super easy, it depends a lot on your images, but yes, you can perform benchmark and then decide what's the best architecture according to your data. Yeah, there are libraries for doing that. And yes, in general, yeah, this is the way
Which one
in which you, this is the way in which you augment, it means your data. You have few data, but you create synthetic data, adding noise or cutting part of the data, and so.
But you don't do it.
No, it's automatic. Yeah, exactly.
Okay.
Yeah, Montessori approach, like let them play.
The end of the day, you have to train an AGI with data that you give it. Do you think that's right? No. Do you think the AGI will be able to suspect at least that its data is biased?
Well, there is a nice story about that. Training similar to GPT model, they want to understand if the AI was able to find a really small concept in many books that they gave to the AI. So they takes a lot of economy books, a lot of mathematics and stuff, and within all this book they hide a phrase saying, okay, the best seasoning for pizza, it's with pepperoni, something like this. And then they train with all these books and just this small phrase hidden in the context, and then they say to AI, okay, what's the best seasoning for pizza? And the AI said spontaneously, okay, it's with pepperoni, but I suspect that this is a test because this information was hidden in tons of unrelated material about the economy. So there is start to be a kind of self-reflection. So it could be that even if we present biased data, the AI is able to generalize and understand, okay, maybe the world is something more, something beyond the data that I'm taking as input. And also consider that all this stuff here, the reasoning model, they're not working with data that we give them. There is one AI creating synthetic data for training, and then the synthetic data are used for training. So it's kind of retroalimentating loop. So, some years ago there was the concern about, okay, there are no more data, there are not enough data for training a good AGI. but then most of these problems are somehow solved with synthetic data. Okay, so also this test here, you can generate 1,000 of this kind of puzzle, and you can train a model on that.
We have more philosophical question.
Perfect.
I'm not using ChatGPT. I have never used it. I don't even have it in my computer, but I know that everybody uses it.
Yeah.
So I sort of think that at some point I will have to use it because otherwise I would be completely, I don't know.
Yeah. I'll
outside the
perform. Yeah.
world. Yeah, I will not perform at the level I should. Do you think this is the way it is? I mean, it's impossible, right, to perform at the same level as people using ChatGPT, right?
Unluckily, yes, there is no way. I mean, yeah. Especially if you know what you're doing and you are somehow assisted by ChatGPT, you can be super productive in a way. You can do in a day, you can do 10 times the things that you were doing before using that. So, of course, maybe there are many things in which it's not perfect yet. You can still your human value. It's a value. Okay, so but I'm scared that this is not gonna last a lot.
Not a big value anymore.
Exactly, yeah. You know, that actually I was wondering now how many quotes of them of this kind of style put in this presentation. One of the famous quote was also from Sam Altman, the creator of the founder of OpenAI, and they say it's a kind of a concept that I liked. We released ChatGPT to the public maybe 10 years before what Google was suspecting to do, no? Because Google was the people that discovered the transformer and so on, and they did that in 2017, and they want to release something to the public in 2025. But in the end, and so they want to test it a lot before releasing to the public. Instead, OpenAI just released that in 2020 and so on, because they said, we want people to co-evolve with this technology. We want people to be prepared to the fact that in a short amount of time, the value of intelligence is gonna decrease a lot. And so, yeah.
But what if you don't know anything or you don't know much? You can still use all these
Let's say
tools and perform well.
let's say that one of the key difference of this technology compared to computers or internet and so on, that the learning curve, it's kind of flat, because you can actually talk with AI or write to AI, but it's not something that you have to learn. Maybe, you know, when we were kids, they say, you have to learn to use Excel, no? And it's like, it was a mess to learn how to use Excel, and we were good with that, we were genius. But it's not something really complex to talk with someone, to write to someone, and then to take the answer, maybe read the answer. So I have example of people, example in coding, this is pretty clear to everyone. I think that even if you don't know nothing about programming, with the advanced AI, you can ask for something and then get the code, copy the code, and use the code.
Yeah, I have seen that, but it's not that risky because it is
Yes.
super wrong.
Totally, and we can also get stupid. Actually, there start to be some research that people, after using a lot of ChatGPT, they get, of course, lazy, but they also get a bit more stupid, of course. Yeah.
Yeah.
No, it's dangerous in many
I
ways.
think we'll all get more stupid. Okay.
Maybe it's first.
Yeah, I haven't used it a lot, but one thing I've noticed is that when you use ChatGPT or others, you know, for bibliographical research, for
Yes.
example, they hallucinate.
Yes.
So that stopped me from using from this particular technique. But I don't know if there is if you could explain why is this happening and how can we detect it?
Yes, I actually, maybe didn't focus too much on this, but the reasoning of hallucination, well, let's say that even human hallucinates sometimes, you know, because consider that the neural network of AI, ChatGPT and so on, it's much smaller of one of the brain, of the one that we have in the brain, and the data that enters into the that we use to train the neural network is there a lot, so they get a bit confused sometimes, and the problem is related with this, with really things in the beginning, the perplexity, because when you measure what you expect and what actually it is, there is always some kind of overlap, and so this generates noise in the way you train. So this is mostly the problem of a training method that you use. And one of the way, of course, there is this problem of for the bibliographical reference, but one of the way that they discovered to reduce this problem a lot, there are some metrics, is the use of reasoning. And this is something that it's pretty recent. So maybe I invite you to try again, because I mean, this is, of course, you have to pay if you want to use it for ChatGPT. But with the payment, with the pay version, you have access to the reasoning model that hallucinates much less, and actually it's able to perform a bibliographical research. Now, I think if you pay 20 euro per month, you have 10 deep research questions in which the hallucination are much less, because they actually do this. They check where it is. Here, they reason what they're doing, you know. So if they start saying bullshit, they say, "Oh no, wait, maybe I'm saying bullshit." Then they start again.
I developed this theory that at some point that they seem to be unable to say, I don't know. They have to always answer something. Is that bullshit?
Yes, no, actually it is in the way in which they were trained before, because before they were trained to just like autoregressive model, so they just have to say a word, say a word, say a word, say a word, and possibly a word that we like. Okay, so if we train that model, Noam Chomsky said that we were training stochastic parrot, just saying something, just say something, whatever it is. So yes, this is a problem, but with this kind of approach, the Monte Carlo research that is getting much more tuned on this problem of the LLM, I think that this problem can be solved. And now it's much easier that the AI say, okay, I don't know the answer, but maybe you could do that or that. So especially for scientific discoveries, this is going to be quite a revolution, because it starts to be, if you talk with this very expensive version of ChatGPT, you can really start to feel that there is kind of a colleague on your side, and maybe it's not saying the first things that it says. Actually, it takes time to reason, because it's not an immediate answer. It takes could take also hours to answer you, and then after it thinks a lot, to say, okay, I think on that, and I think that you can do that or that. So it's mostly a problem of the old LLM.
Yeah, mine is a curiosity. I'm ignorant in this part, but I've read that these technologies use a lot of energy.
Yes.
And I was wondering if you think the added value of using them for fighting climate change, for example, or environmental conservation or research will outweigh the energy cost that this technology uses.
Yeah, no, this is a common idea. Well, there are different aspects, sometimes personal, sometimes more objective, but we are using many energy for really stupid things, like every video on YouTube, every movie on Netflix, every message that we send with WhatsApp, it's using a lot of energy. And of course, yeah, AI is using a lot of energy, still using a lot of energy, but this is something that is changing really fast. So like with this technique of, well, I didn't mention too much, but there are techniques that are called neuromorphic neurons. So they are much more similar to how actual neuron works. And these are much more energy saving. This is still something that's it's work in progress, but the fact that AI is using a lot of energy is not going to last a lot. And it's not even using so much energy as we think. And then there is the idea that if we are using this energy to develop new drug for cancer or whatever, I think it's still better than using for YouTube or whatever.
Yes. Cool. I have a question related to what Sylvia said. There's something that I don't
maybe you know, which is when we talk about the energy of making a question in ChatGPT. I understand that there are two parts of the generation of AI that consume different amount of energy. So, like when you take a plane, the part which takes most energy is actually to go up. And then once you are like at a certain height and you just go straight, the energy consumption, it's order of magnitude below maybe the one that you use for the ramp, initial ramp. So in the training of artificial intelligence, I understand that there will be a part of training, which is the most energy consuming, but once you
inference, it's called inference.
Like the plane, it's the part when you're just going straight.
Exactly.
So when we read online this concern about the energy that takes doing one search on ChatGPT, do you know if these calculations that we see are made on the, like, how are these made? Like, do they take into account like everything that happened before, like also the training? Because then I said, once it's trained, do I have to feel guilty for using ChatGPT?
Okay.
Once it's trained,
No.
what is the energy consumption of my individual?
Okay, so you said really, really good, because there are two phases. One is the training, that it's really energy consuming for this process, that the information has to travel back and forth from the network, and it's a long process. But once the training is over, the process called inference, it's kind of straight, and it's much less consuming. And actually, in a really recent paper on Nature, I think 1 or 2 months ago, they, since many people say that, they checked the CO2 emitted by people like writing a text on, I don't know the topic, but they compare the CO2 emitted by a human writing something and the CO2 emitted by ChatGPT in writing the same quality text, and it was much less.
Okay.
So I don't push people to don't use too much this concern about CO2, about energy, because sometimes someone will come and say, okay, humans are too energy consuming. Let's reduce human and use AI. So anyway, yes, inference is much less consuming.
Yeah, I guess the more we use it, so the more I type do this, the more maybe they will develop, consumer pushed.
Yeah, it's a bit of a pity that most of the money in the industry are not in this aspect of AI, not like saving energy. But there is a small part of Freaky that likes this kind of networks, and so there is a small community that is developing about how to make AI really efficient, copying their brain, how it works, and so on.
Okay, so.